our science guys say this might be the biggest break in their lifetime so far. Matt Sellen, a morning show regular wise guy from the University of Illinois, joining us this morning with a special guest.
Well, it's such a big, exciting thing in our community that I didn't want to try to explain it myself because I would mess it up. So I brought an expert in. This is Professor Brian Fields, who's both in physics and astronomy, who can tell us all about the observation of primordial gravitational waves.
Ooh.
All right. Well, thank you, Max, and thank you all. I'm really excited to be here to share the news. So 9 days ago, a team of astronomers announced an astonishing result. And if it's confirmed, it will win a Nobel Prize for sure. And the measurement itself is spectacular. And I brought a couple of pictures.
Okay.
And could we share the first one?
It's in there.
Yeah, there we go. So, so what were observed are cosmic radio waves, not visible light, but radio waves. And what you're seeing here is the telescope that took the picture. So on the bottom of the image, in the foreground, what you're seeing is the BICEP telescope, which is a radio receiver. It's about the size and shape of an oil drum. And you'll see that the observatory is in the South Pole, which is a great place to do astronomy. It's bristling with telescopes because it's the next best thing to space. It's high and it's dry. So, why do we look at the sky with radio vision? It's to learn about the very early universe. So the idea is the universe is expanding. Galaxies are rushing away from us. And so in the past, the universe was denser and hotter. And this idea was confirmed 50 years ago when astronomers stumbled on a glow of the cosmic fireball, which is now invisible to the eye, but can be seen in radio waves. So we know the universe began in a hot, dense state, which we call the Big Bang, but this leads to all sorts of questions. What banged? How did the universe get the way it is today with stars and galaxies? And from here on in, the answers will sound like science fiction. So, in the 1980s, theoretical cosmologists developed a bold idea called inflation. And according to inflation, the entire observable universe was once microscopically small, but filled with enormous amounts of energy that drove the universe to expand a trillion times in the blink of an eye. And so inflation claims that our observable universe grew from microscopic to astronomical scales in a tiny fraction of a second. And this inflation theory made several predictions, many of which have already been confirmed, but one key test remained. Because the idea is this rapid initial expansion was extremely violent and created gravity waves, gravitational radiation, ripples in the fabric of space and time. And that is where our intrepid astronomers came in. This BICEP radio telescope was built to find the signature of these gravity waves. And that signature was seen. And so could we show the second picture? So this is what the telescope saw. This is a map of the sky as seen in radio waves, and it's enhanced to bring out exquisitely fine detail. And the new discovery here is this swirl pattern. For the experts, these lines show radio wave polarization. And the curlicue pattern you see can only be created by gravity waves, by gravitational radiation. And so this image tells us that the entire universe is indeed bathed in gravity waves. And amazingly, this swirly signal was predicted by inflation theory, and its detection is a dramatic confirmation of inflation. And if this result holds up, it unveils the earliest moments of the Big Bang, stretching back to a time when all forces of nature were unified. In these first instants, the laws of the very large and very small, gravity and quantum mechanics, were somehow reconciled in quantum gravity. So I know this all sounds like science fiction, but amazingly, these bold and strange ideas can now be studied in the cold light of observation.
So looking back at history and obviously a new discovery, what does this mean, if anything, moving forward? I mean, is there now 1,000 million new questions, or what does that yield?
Absolutely. There are many new questions. And the first thing is, this is science, and the hallmark of science is the results have to be reproducible. So this result needs to be confirmed. It just came out last week. The results were first announced, and so we've got to check the results. But I'm very confident these will pass with flying colors. But there's much more to do. We've now made this great discovery. We want to really understand this process of inflation. And if this signal is there, the way the BICEP telescope tells us, many other telescopes will be able to see it. And soon we'll be able to study this process in great detail, getting a detailed picture of the earliest moments of the Big Bang. And the University of Illinois will play a key role in this. University of Illinois astronomers and cosmologists will be important in both the observation and theory of this amazing new time.
And also, it might mean that it could take me longer to travel to a different galaxy.
So,
I might help you figure it out.
Well, this is fantastic and disappointing news.
Here on the show.
Guys, we really appreciate this. We'll have this on IllinoisHomepage.net for you to mull over a little bit after the morning show today. We'll be right back.